Welcome to 0% Stock. Today, Quicksort, one of the fastest sorts on average, and one of the easiest to accidentally turn into the slowest. We'll build it in Rust, then fall into the famous ON² trap on purpose so you never hit it by accident. Beginner friendly. Quicksort is usually ON log n and blazing fast. But one bad decision, how you pick the pivot, can quietly make it ON². Let's see both, live by counting comparisons. If you like algorithms explained clearly, I like really helps. First, how Quicksort actually works. Quicksort picks one element as the pivot. It partitions everything else into two groups. Smaller than the pivot on the left, bigger on the right. The pivot is now in its final position. Then you recursively sort each side, divide and conquer again. Here it is in Rust. With the sum of the sensible pivot, the middle element will split into less and greater, counting each comparison, then recurse and stitch the results around the pivot. Sort 2000 items with the middle pivot, about 18,000 comparisons. That's the n log n we expect. When the pivot splits the data into two roughly equal halves, you get about log n levels of recursion, each doing n work. That multiplies to n log n. The key word is balanced. Now the trap. A very common beginner choice is to always use the first element as the pivot, but if the data is already sorted, the first element is the smallest, so one side is empty and the other has everything else. No balance, watch what that does. Same Quicksort, one change, the pivot is v at 0, the first element, and we'll feed it an already sorted array, the worst case. Same 2000 items, nearly 2 million comparisons, that's ON². 100 times more work for the exact same result. 18,000 versus almost 2 million on identical input. Every partition peeled off just one element. So instead of log n levels, we got levels, the textbook ON² collapse. Trace 1, 2, 3, 4 with the first element pivot. Pivot 1, nothing is smaller, everything else is bigger. Pivot 2, same. Every step peels off a single element. Now that's some levels of recursion, the definition of the worst case. The fixes are easy. Așa că pick the middle element, a random element, or the median of the first, middle and last. Any of these means no particular input. Johnny sorted, reversed, whatever should can reliably force the worst case. Caprice? So Quicksort is ON log n on average, but ON² in the worst case, entirely decided by pivot choice. A good pivot also keeps the recursion depth around log n, which matters for the stack. One note, production Quicksort partitions in place for one extra space. Ours copies into vectors to keep the logic obvious, but the pivot lesson is exactly the same either way. Common mistakes: a first or last pivot with no randomization, which dies on sorted data, mishandling elements equal to the pivot, and the deep recursion of the worst case, which can even overflow the stack. Recap: pick up a pivot, partition, recurse. Balanced splits give ON log n. A naive pivot on sorted data gives ON². Choose the middle random element or median of 3 and you're safe. Quick one, if this helped you, the wallet's on screen and there's a coffee link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.